Okay, this is a sample problem for problems number 2, number 5, and number 7 in the anaerobic sludge chapter 11. So quite a bit going on in this problem. So let me first say that I'm not really wild about the way the problem is written. Daily gas production is important to note here. So daily gas production, which you were given, 22,000 cubic feet. So we're actually missing, usually typically these word problems have clues in how to set them up, and there are clues on how to set up the problem most of the time. In this case, really, the question is not written in a way that allows you to understand how to set the problem up. So the way that we are setting this problem up is gas production of 22,000 cubic feet. We're given that. So 22,000 cubic feet. The rest of this information we are going to use to determine how many pounds of volatile solids are actually destroyed in this digester. And so we need to use the 10,000 gallons per day. The sludge solids content of 5%, the volatile solids content of 67%, and then the volatile reduction of 58%. So we're going to have a relatively long equation here that's going to go on actually on the bottom of our equation. So first we have 10,000 gallons per day. Now, for the purposes of this problem and the other problems in this chapter, we're to assume that this sludge weighs 8.34 pounds per gallon, or has the same density as water, which honestly is typically not the case. Otherwise, it would not be sludge. Usually, sludge is going to have a slightly higher specific gravity than water, which is why it becomes sludge, because it sinks to the bottom of a tank and separates from the water. But so most of the time in practical application, you're going to add a specific gravity component to this equation, but we're not doing it here in the homework because that's not how they set the problems up. So 10,000 gallons per day times 8.34 pounds per gallon is going to give us the total pounds of sludge. Okay, next we add, or multiply, excuse me. I'm trying not to get my math terminology messed up here. This equation includes 0.05. Okay, sludge has a solids content of 5%. So out of this 10,000 gallons times 8.34 pounds per gallon, only 5% of it is solids content. All right. Next, we multiply by 0.67 because out of that solids content, only 67% of that is actually volatile content. So now we've been able to determine how many volatile pounds of solids material have been pumped to the digester, and then last we've destroyed 58% of those volatile pounds as given by our volatile reduction. So we're going to multiply all of that together. So we're going to keep our 22,000 cubic feet of digester gas divided by, and let's multiply this out, 10,000 gallons times 8.34 gives us 83,400 pounds times only 5% of that is solids. So times 0.05 gets us down to 4,170 pounds times 0.67, because only 67% of those pounds are volatile, gets us to 2,794 volatile pounds, and then times 0.58, because 58% of those volatile pounds were destroyed. By the time I'm done multiplying that all together, I have 1,620 pounds that were destroyed. And then my ultimate answer is going to be a division problem, dividing 22,000 cubic feet of digester gas by 1,620 pounds of volatile matter destroyed. And I finish with 13.58 cubic feet of digester gas per pound of volatile solids destroyed. So I think this problem, to be properly written, ought to be asking what is the daily gas production per pound of volatile solids destroyed. But that is not how it's written in these questions. So this is how you're going to set up all of these problems. Again, problem number 2, problem number 5, and problem number 7. What we're trying to calculate here is how much digester gas is produced per pound of volatile matter that's destroyed in the digestion process. So that's how you set the problem up. Good luck with that one.